All right, so this is the review you guys did in class, and I just wanted to go over the answers so you're able to get the correct answers to study off of. So you have to fill out this chart. You have the same one in class, but if I was to fill it out, I would put rational. Then you have your integers, then your whole numbers, and your natural numbers. Sorry for the sloppy handwriting. And then over here by itself, it's the irrational numbers. And why did I do this? I did this so you're able to classify the numbers and you can say, okay, it's rational integer or it's rational integer whole for the next activity and just in general. Like I said, you could have put before I said you could put the definitions in there, examples if you wanted to. This is just good if you wanted to print it out or study off of it. So next is the Google Sheets. That was loud in my ear. Next is the Google Sheets. So if we look here, we want to type in all the correct categories. So 5 is our rational, integer, whole, natural. And I did that wrong. I'm supposed to put IN. And it turns green, so that means I am right. This one would be an irrational number, so I put an I. This one's just rational, so I put an just fills it in. I don't want it filled in. I put an R. This one, 20 divided by 2 is 10. 10 is a rational integer, whole, natural number. Negative 90 is a rational integer. So we know it's a rational integer because it can't keep on going. If I look at whole numbers are only 0 and up, so our negatives are not involved. The square root of 8, if I put that in the calculator, it's an ongoing decimal, so that's going to be irrational. Lowercase I. 0, we know 0 is rational. We know it's an integer. And then it's a whole number. It's not natural because natural goes from 1 and up. Negative 8/7, anytime you see it as a fraction, it's automatically rational. The square root of 81, this is one of our perfect squares that we need to memorize. The square root of 81 becomes 9. 9 is a rational integer, whole, natural number. And 17.58, this one becomes confusing to some of us, but when it stops, there's no dot, 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 it terminates, it is just a rational number. So those would be the answers to these problems. So make sure you guys understand these type. You are going to be seeing it on your quiz. And then let me present this. All right. So this is when we are going to give the general cases. So I showed you up here that natural numbers are 1 and up. Whole numbers we know start at 0. 1, 2, 3, 4, 5, and keep on going. So this is just all the cases. So you might stop at 4 if it's a set of whole numbers between 0 and 4, both inclusive. You would stop at 4, but this is just a general graph to show you that it's 0 and up. Your integers, we are all the negatives. This takes a while to draw. And they keep going both ways. And your rationals, real numbers. Your real numbers are the shaded in line. So every time you have real numbers, it's your shaded in line, and it can keep going forever and ever. So yeah, these are what your graphs should look like. I put this on your optional homework in a better drawn out system, so you can take a look there as well. Next, we're going to be filling in our graphs to graph them properly. So if we have the set of real numbers less than 1, anytime you see less than, you put an open circle on it, and it's real numbers, so we need a line. Because it's less than, we're going to the left, so you just need a shaded in line to the left, and because it's less than, we put an arrow, because it's all the ones less than. So if it could also be negative 20.567889, blah, 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 and so on and so forth. So that's why we keep the arrow, keep on going. Now we have the set of integers greater than or equal to -1. So if it's greater than or equal to, we shade it in, filled in circle. It's integers, so we put dots. And because we have the term greater than or equal to, we put a nice arrow at the end. Now we have the set of whole numbers between -2 and 4 inclusive. Inclusive tells us we have a filled in circle. However, we keep going down because we have our dots, and whole numbers start at 0. So we can only, I don't know why that happened. We can only put it on 0. Can't put it on -1, -2. You could put open circle on -2 to say we started there, but you can't put a closed circle. You can only do it on the whole numbers, and that's why the last activity was important, because it showed you whole numbers only start at 0, so you can't fill these in. Then we have the set of natural numbers between 1 exclusive and 4 inclusive. So 1 exclusive is an open circle, 4 inclusive, and we put dots in between. And this one's okay. This one we don't need to change it because natural numbers do start at 1. It's okay. Then we have the set -3, 0, 3, and 5. So this is telling you that these numbers are in there. So we have -3, we have 0, we have 3, and we have 5. And that's all we would do. And then we have the set of real numbers between -4 and 4, both exclusive. So anytime you see the word exclusive, it's an open circle. So -4 and 4. And because it's real numbers, we shade it in. And that's some ugly shading, but that's okay. You guys get the point. All right, good. So now we are going to name our graphs. So if we look at the first one, this is our special case. We would say the set, squiggle line, -4, 0, 3. You're only going to list the ones that are included. You can't say the set of integers, between -4 and 3, because these aren't included. So you have to just pick the ones that are included. And this one, you look and you're like, okay, there's negative numbers that have dots on them. They have to be the set of integers. So the set of integers. We have an arrow at the end, so we have to use one of our terms that are greater than, less than, and such. And this is filled in, so it's greater than or equal to, or equal to -3. We have an arrow on the end here. We have a shaded in line. The shaded line automatically tells us that it's the set of real numbers. I don't know why that keeps happening. Numbers. And because we have the arrow, once again, we need a greater than, and it's shaded in, so we're going to say greater than or equal to. -3. So these two are very similar. The only difference is we wanted to show shaded in line as real numbers, dots are integers. This one we have integers again because they're on negative numbers. So we would say the set of integers. We have endpoints, so we have to say between. And they have different filled in and not filled in. So we're going to just separate them. So we say between -2 inclusive and 4 exclusive. Take a look at the next one. We see we're working with real numbers again. So we say the set of real numbers. And because it's an open circle, we're going to say less than 1. We have the arrow and the open circle, so it's less than. Then finally, we have the one on the bottom. And I gave you this one because I wanted to show you that you can name it integers. You can name it whole numbers. You can name it natural numbers. Any of those 3 work. Like I've told you in class, if you want to play it safe, always name the dots integers. If you want to show your knowledge, you can say natural numbers, whole numbers. Those show that you're a little bit advanced with this material. So I would say the set of natural numbers between, because there's no arrow, 1 and 5, both inclusive. So you could write between 1 inclusive and 5 inclusive. I just like to save writing, so I say 1 inclusive and 5. 1 and 5 both inclusive. That's the easier way that I think. So yeah, this is how you do it. If you have any questions before the quiz, obviously, please email me. I would try the homework assignment that's online just to really strengthen your knowledge. If you have questions on that, email me as well, all right? Have a great day, guys.